the rest in US and Canada, and indeed Brazil and Argentine. And a very good afternoon to other folk in UK and Europe, Africa, and good evening to Hong Kong, Malaysia, and of course, particularly in the afternoon in Israel. A very good afternoon, Professor Amnon Kami. Welcome here to this webinar. Thank you very much. And Barry has also joined us. Very good. So now we are all ready to go. Okay. So very good morning, good afternoon, good evening, and good night to my colleagues from Australia. That's Des and myself here and a few others. We're very delighted to be here today for a very interesting and indeed informative conference, international conference that we're going to have. So I welcome all of you on behalf of the Department of Education of the International Program of the UNESCO Chair in Bioethics, the University of Haifa, and of course the Department of Education is based in Melbourne, Australia. I want to welcome the head and chairholder, Professor Amnon Kami, who has joined us from Haifa and from Israel. Very welcome to you. And then I will, before I introduce, I want to welcome all the distinguished panelists here. And you will be, I'm delighted, I'm sure you'll all be delighted to know that we have a very distinguished panel that represents all the regions of the world, North America, South America, Europe and UK, India, China and Hong Kong. So we have a good program. But before I introduce all these distinguished panelists, I'll invite Professor Mary Matthew, the co-chair, to welcome you and to say a few words, as would we do to Dr. Derek, Colonel Derek, who is the moderator of the chat box and the questions and so forth. Over to you.
Thank you, Dr. Russell, and welcome to all our panelists and speakers for today, and of course to all our participants. As Professor Russell said, we have a global a participant community here, and I'd also like to welcome our friends from the Kurdish Republic of Iraq. Welcome to them too. And this is our 35th webinar. So we've been going strong ever since COVID happened and this pandemic happened. And of course, today's topic, we will deal with something that is very important and what has been in our minds, that is vaccine and the newer treatments that are coming in. And of course, the shortage of vaccines and the different types of vaccines, and also, of course, the distribution of vaccines. So these are our topics, and it's going to be a very interesting webinar today because we've got eminent speakers from different parts of the world who are going to share their knowledge. And as usual, I welcome all of you to please put your questions in the chat box. Feel free to write, and to the panelists and to the speakers. If you wish to respond to any of the questions in the chat box, please feel free to do that too. So with that, I'll just hand over to Dr. Derek, who will be moderating the chat box, and he will give you a few housekeeping rules. Thank you.
Thank you, Professor Mary, and welcome once again. It actually feels like family back here because so many familiar names, and every time we just have one or two new names. So welcome to that, and I'm sure we'll keep seeing you all here in the future. I have posted a link in the chat box, which is the simultaneous YouTube live streaming of this webinar. So you can share that with your colleagues and friends, and they can watch this webinar, at least even if they are unable to log into Zoom. Later on, a recording will also be available at the same link. So in case some of you would like to download that later as well, please feel free to do so. As Dr. Mary requested you all, while the discussions are on, in case there is any question that you would like to respond to, kindly do the same in the chat box, because then it becomes information for all of us. Again, if there is any article or document or link that any one of our respected panelists would like to share, you may again attach that in the chat box, because it remains as a permanent record. So we have quite a number of students from all over the world who are here as co-learners. So they would like to download those links as well. And we can also put them together at the end of the webinar. So welcome once again. Good to have all of you. And I'm sure we'll have a scintillating discussion this time around. Back to you, Dr. Russell.
Okay, thank you, Mary and Derek. Now, this program today has two parts to it. We have the first part, which is going to be two very distinguished speakers who are going to present. One part of it is about COVID mutations. We're all hearing about that. We are concerned about that. So that's going to be discuss the implications on infectivity, mortality, vaccine efficacy, lab testing, and monoclonal antibodies, convalescent plasma efficiency. Dr. K.K. Agarwal will be presenting that. Now, Dr. K.K. Agarwal is the president of the Confederation of Medical Associations of Asia and Oceania, but he's also the president of the Heart Foundation in India. So, and then we will have Professor Dr. Matthew Weiner, a professor of medicine at the University of Colorado School of Medicine, but importantly, he's the director of the University of Colorado Center for Bioethics and Holocaust at the studies. And of course, he's going to bring in a very important aspect, the ethics of allocation of scarce vaccines and monoclonal antibodies. And I have requested Matt to chair this first part of this program. And then we move to the question and answer session with the panelists from around the world covering the global aspect. And that Professor Mary Matthew will moderate that part of it. And coming back to the panel, we have Professor Matt Weiner, who will represent and tell us with regards to North America. We have another very distinguished panelist, Professor Martin McGee from United Kingdom. He is an advisor to the WHO and also to the European Union, but he's also a member of the Scientific Advisory Group on COVID-19 pandemic in the United Kingdom. So we're very delighted to have you, Professor Martin, and welcome to this program. And I'm then delighted to also bring to introduce to you Professor Barry Schwab, who is the chair of the Ministerial Advisory Committee on COVID-19 vaccines for South Africa and a professor emeritus on virology from the University of Witwatersrand. Am I right? Did I pronounce it right, Barry?
Witwatersrand. It's actually Witwatersrand.
Witwatersrand, right. Thank you very much for that.
Sure.
Yeah. And that is, you're in which part of South Africa? Which
Johannesburg.
Johannesburg. Welcome, Barry. Welcome here. Yeah. And then I have another very distinguished panelist, Professor Antonio Chagas from Brazil. But Professor Antonio Chagas is also the president of the Cardiology Society in Brazil and the American Cardiology Society, the Brazilian chapter. But he's the chief of cardiology at the University of Sao Paulo, and he's done a bit of work with the COVID, and so he's here with us. And I'll have welcome Professor Antonio. I look forward to learning from you about the region. And then we have Professor Siddharth Sridhar. Siddharth Sridhar is a virologist from the Infectious Disease Department of the Hong Kong University in Hong Kong, China. So welcome, Dr. Sridhar, Professor Sridhar. We'll look forward to learning from you. And finally, I have Dr. Lincoln Ferreira, Lopez Ferreira, who has joined us. He is the president of the like KK's Confederation. He's the president of the Ibero Latin American and Caribbean Medical Associations. So we have covered all of you together, brought the world together. Now, very importantly, the Universal Declaration of the UNESCO has article on solidarity, and we have taken that up. And so part of what we do here is also contributing to the solidarity where we are together in this world, taking on and coming through this pandemic. So without any more delay, I'm now going to hand this to Professor Matt Weiner, who's going to share this part, the first part of today's program. Over to you, Matt.
Thank you so much, Dr. Russell. I really appreciate the opportunity to be with everyone today. Dr. Agarwal and I are going to spend the first 20 minutes or so doing a couple of presentations. And Dr. Agarwal, I apologize for jumping the gun on this. I'm not sure if you wanted to go first or if you wanted me to go first.
I'll go
so,
first.
If you're okay going first, that would be my preference, because I think you're going to give some very important background information. And then I will speak a little to some of the ethical issues associated with the implementation of what you're going to be talking about. Is that okay?
Yes.
Okay. Thank you.
So thank you, Matthew. Thank you, Dr. Russell, Dr. Mary, Dr. D'Souza, all my colleagues who are present here. I bring you greetings from Confederation of Medical Association of Asia and Oceania. And we are going to talk about a fight between human intelligence and a viral intelligence. All your questions asked by Russell will get completed into that. So I say there is a fight between human intelligence and the viral intelligence, and how it works is going to be my talk. This is my 1,640th interaction in the last 9 months on COVID. And on this particular subject, Dr. Ganguly, Ashok Ratan, N.K. Arora, Angelique, Pavitrata, Navidita, Jayanti Shastri, Anita Chakravarti, J.M. Kaul, Ved Mishra, etc. I have interacted with them. They are all experts in India as far as mutations are concerned. Now, whenever in a country, whenever you find a new wave, and if the second wave is stronger than the first wave, in spite of a lockdown, or if you see in the community cases of reinfection occurring much more commonly, you rule out a mutation. That's the time to look for a mutation, that the virus has mutated. This lecture becomes important because the Prime Minister of UK said that the new mutation can be more deadlier, and now the Brazil has shown that 2 mutations can occur in the same patient. So this becomes now a matter of concern to us. In the vaccine era, 2 patients in Brazil have shown P1 and P2 strain, which I will discuss later, in the same patient. Now, if these 2 viruses enter the same cell, that's what the virus wants. Virus would like to enter a single cell with 2 strains, and that what is going to happen is going to be a problem. So coming back to some of the definitions, variant, strain, lineage, mutant are interchangeable. When I speak, there will be mutations which are VUI, that is variant under investigation, which is majority. There are 4,000 mutations which have happened. Out of them, only few of them will be VOC, that is variant of concern. And only one at this moment is variant of most concern. So therefore, when I speak, so therefore, out of 4,000 mutations, only a few will be variant of most concern. Now, when you have a mutation, the mutation can be synonymous or non-synonymous. Synonymous is like AAG is lysine, AAA is also lysine. So if this G becomes A, the amino acid does not change. But if it becomes UAG, it becomes a codon, and the virus will stop functioning further. But if it is AGG and G is replaced by C, arginine becomes threonine, so this becomes non-synonymous. So we will hear a lot of words about, so we are looking, virus would like non-synonymous mutations as much as possible to its favor. So that is what the virus wants. He doesn't want synonymous mutations because that's not giving him any advantage. Now this is how the virus looks like. And you can see in the virus, this is the ORF1, ORFB, and then comes the spike protein, and then comes different types of E, M, and N nucleoproteins. There are 30,000 amino acids in the SARS genome, 29 different kinds of protein. Mutation is 1 to 2 mutations per month. Every amino acid till today has done 4 mutations till today. So every amino acid has mutated 4 times. Just 1 second. Yes. Not all mutations result in change in the proteins. Non-synonymous and synonymous I have already said. And a change in amino acid may or may not be functional. Now this is an important slide which will come again and again. There is a SARS virus above, and there is a MERS virus genome in the lower down, and you will see MERS minus SARS in the spike protein, it has 98 less amino acids. So what has done in the MERS is all accessories amino acid it has deleted and become a SARS-CoV protein. So deletion becomes very important. Now here you can see here the frequent locations where mutations can come. If a mutation can come in ORF1A or ORF1B, the lab will not work. And if the mutation comes in the region of E, because E is the fundamental principle for lab diagnosis. So for the purpose of lab diagnosis, viral would like to have a mutation in ORF1A, ORF1B, or in the E gene. So if there is a mutation in E gene, ORF1A, ORF1B, you will have a difficulty in diagnosis. Now if you see here, this is the spike protein, and the RBM portion of the spike protein has lock. This is a locking system 3 down. 1 up, 2 down, 2 up, 1 down, and 3 up. Now, these are the situations which are blocked by various antibodies. Now, this is how we classify different types of with different types of antibodies produced, class 1, class 2, and class 3, depending upon which arm they paralyze. Now, this is a slide from Oxford vaccine, but I only want to say is that a spike protein is trimeric. You can see a femur-like protein. 3 proteins makes 1 spike. So 1 spike basically has 3 components. Each one of them have a different structure. And this slide shows that virus want to survive. Survival of fittest is, you can see mutations on the left side occurring, and only few of them are surviving. Now, why do we do a genomic study? We want to do a genomic study to discover the virus, develop diagnostics, develop vaccines, track transmission, identify reinfection, understand host viral interaction. Now, what does the virus want? A virus wants to survive. So therefore, a virus would like to become like a Hep C or Hep B. It will like to cause chronicity in the body. That is what every virus would like and aim to survive in the body forever without killing the person. It will like that it is not detected. So it will mutate in such a way that it is not detected by the current laboratory methods, which I have shown you just now, either ORF1A, ORF1B location, or E gene location, or it will like to delete some of its amino acids so that it changes the shape of the spike protein so that it is not detected. It will like that neutralizing antibodies don't work on it. Therefore, it will come back and it will like to block this 3 up, 2 up, 1 down, 1 up, 2 down, or 3 down. So it will like to have a mutation in these sites. It will like to have that vaccines don't work. So therefore, it will like to have mutations in RBD and RBM. It will like plasma should not work on him. Therefore, it will like mutations on RBD and RBM. Now, these are the portions of the viruses which causes different actions. Now, the most important thing is NSP14, which is responsible for proofreading. Now, if there is a mutation on NSP14, and if the proofreading mechanism goes away, mutations will occur much more earlier. So a virus would like a mutation of NSP14. Now, these are different areas of the virus. Say, for example, ORF1AB causes viral replication. So if there is a mutation in ORF1AB, there will be more and more of virus replication, defective proofreading. It will suppress cellular immunity, etc. And then we have same thing. So if it has a mutation in envelope, it will impair the virus assembly. The virus assembly will increase. If it is a mutation in ORF3, the virus release will hasten. If it is a mutation on membrane, it will cause the virus envelope to be defective. And if it has a mutation in nucleocapsid, the interferon resistance will develop. Therefore, the interferon 1 alpha and gamma interferon protection will be impaired. Now, coming back to this structure again, what does the virus want? So virus wants that the whole country, the whole world is only talking about S protein. So the virus now will concentrate on S protein mutations. He says 679. See here, there is a 679, which is bifurcation of S1 and S2. So the virus will go on mutating till it mutates 679 to its advantage so that it enters the cell very easily. Virus would like to delete as many amino acids as possible so that the structure gets changed. And here comes 69, 70, and 145 deletions. Virus would like to have a mutation in RBD and RBM So a virus would like a mutation between 318th amino acid and 424, which is RBD, between 424 and 494, which is RBM, and between 494 to 510, which is RBD. So a virus would like, it will go on mutating till it acquires amino acid mutations between RBD and RBM. Remember, all vaccines are made against RBD and RBM. All monoclonal antibodies are made against focusing on RBD and RBM. So therefore, if there are mutations in RBD and RBM, vaccine will not work and monoclonal antibody will not work, the plasma therapy will not work, because they all are designed to cover and kill RBD and RBM. Now, these are the mutations which have occurred, and on the right side are the meaning of the symbol. Say H means histidine, I means isoleucine, L means leucine, like that. Now, these are the mutations. So the mutation, original L mutation doesn't exist. Then came S mutation, which was in ORF8 and which was at 84th amino acid. L got substituted by the S amino acid. Now, out of this, if you see, ever since a G mutation has come, that means D has been shifted by G. And that is how we say D614G mutation, which is the most common mutation as on today. But if you see that 614, which is the predominant strain, it is neither in RBD nor in RBM. So therefore, this mutation is unstable. This mutation is neither in the bifurcation of S1, S2, nor it is in the RBD and RBM. Therefore, the current strain called D614G is unstable mutation, not favorable to the virus. Now, these are the key mutations. These are the key mutations as on today. These are the key mutations. And if you can see here, D614G comes after RBD and before the bifurcation of 679. Therefore, this is a mutation which has only a moderate effect on transmissibility. Then came deletion of 6970, which I will discuss then N501Y and other types of mutation. This slide you can copy and keep it because the time is less. I'm not going to go back into the same detail. Now, the difference between influenza and SARS is influenza does not have a proofreading mechanism. Therefore, influenza has much more mutations than SARS-CoV-2. So if the proofreading mechanism goes away, which is called NSP14, then SARS-CoV-2 will have the same number of mutations than influenza virus. So look for NSP14 mutation. Now, this is what we call them as D614G mutation. Now, this mutation has totally replaced the word that is blue. Earlier, it was D614. D614G means on 614th amino acid, D has been replaced by G. And now, till the UK strain came, the whole world is having 614G mutation. And you can see this is neither in RBM nor in RBD nor at the level of the fusion. So therefore, this increases replication, but also makes the virus more vulnerable to neutralization by antibodies. And the virus doesn't like it. So this mutation 614G was not favoring the virus because it made the virus more vulnerable to neutralization by antibodies. Therefore, further mutation are the only answer. Then a mutation came in Nigeria called P681H mutation. 681st amino acid, proline get replaced by histidine. Now see, 679, 681 is just border to 679. So this is S1, S2 furin cleavage site, Virus says, oh my God, I got it what I wanted. The virus says, Eureka. But because this came in Nigeria, it was alone. It did not get company of other. It fizzled out. But this mutation has also emerged spontaneously multiple times. So UK adopted it. So from Nigeria, 681H instead of P becomes a mutation of concern because it is near 679. Then came 501 mutation from various people, which has come spontaneously because of immunosuppression of people who were immunosuppressed, where the patient's infectivity lasted for months. 501 originated. 501 has two types of mutation, N501Y and N501D. Now, if this N is replaced by Y, it becomes mutation of concern. And if it becomes D, it fizzles out. So wherever mutation 501D came, the virus got destroyed. This is how it makes a changer called Y. If Y is replaced by D, so therefore people are discussing, can we create a mutation in the lab like a genetically engineered mosquito? Can we create a genetically modified virus instead of YD? Then this mutation will fizzle out. Now, this is what I said, that N501Y came from 10 mutations in the spike protein over 154 days. So those people who are persistently infected with the COVID virus are likely to get N501 mutation. So in UK, 501 is available. Then, so this 501 is now available. 681 is now available differently. Now, virus is choosing multiple mutations. Then came N440K in India, which is in the RBM, mutation of most concern, but it fizzled out. That means single mutation, even if it is highly significant, unless there are multiple mutations, it will not create a havoc. So N440 in India, which is asparagine to lysine, though it is in RBM, but it got fizzled out. Then came 6477N in Australia, again in the RBM, but again it fizzled out because Australia did not allow this strain. It was alone, it did not get a company, it fizzled out. In Kerala, we had two mutations. Both of them were in the extremes of the spike protein, fizzled out. And then came Denmark. So in Denmark, in a cluster, this is called cluster 5, it involved 6970 deletion. So this mutation, 6970 deletion, became important because it basically diagnostics cannot check. So all the S gene testing in RT-PCR are dependent on this 6970 deletion. So if you acquire 6970 deletion, that means your RT-PCR will not pick up the spike protein. This is called S gene target failure. So this 6970 and this cluster died out, but this 6970 became a spontaneous mutation here and there. Now you see UK, in the UK, the virus became very smart. So he picked up 501Y because of stronger binding. It was available as a spontaneous mutation. It also added to this Y145 deletion. It also picks up 6970 deletion. And it also picked up 681 mutation. So it picked up 681 mutation from Nigeria. It picked up 541 spontaneously occurring in plasmas, 6970 from Denmark. So now it becomes a mutation of concern. So therefore, now this UK mutation is still unstable because it has only one RBD mutation, which is 501. It will like to acquire more mutations, either RBM or RBD. So therefore, UK mutations cannot be the long-lasting, everlasting. Something more has to come to the UK mutation. So therefore, UK mutation 6970 and 501 Y440 145 deletion and 681 P681H mutation. So therefore, this mutation in UK started affecting children more between the age of 7 to 11 years. And it has these types of mutations, 23 mutations, and multiple of them in the, many of the mutations came in the spike protein. And it started making S gene target failure. Now you see in this, there is a mutation occurring in UK, which is called stop codon in ORF8. Stop codon means a command not to grow further. This is called as a stop codon in ORF8. So this mutation, now let me come back to the slide, original slide. Yeah, this slide. If you see ORF stop codon associated with milder infection, less release of systemic pro-inflammatory cytokines, one emerged in Singapore and disappeared. UK has got ORF stop codon. So therefore, UK mutation is unstable. It doesn't want ORF8 stop codon to be there because it doesn't want, because it has disappeared in Singapore. So stop codon, so in UK, we have only one mutation in RBD. UK is looking for more mutations in RBM and RBD, and it doesn't like ORF8 stop codon to be there. So it would like to mutate further. And therefore, how to diagnose UK strain? And that will be S gene negative. Other genes are positive. You know this is a UK strain. Then came South Africa. In South Africa also, they adopted 501 because it is called V2 because it is other mutations are different from UK. So in South Africa, two more mutations came, K417N and E484K. Now remember this 484, where it is? 484 is in the RBM. Any mutation in RBM is now said mutation of most concern. So this E484K has become now the interest of vaccines, has now become interest for failure of vaccine, failure of plasma therapy, failure of monoclonal antibodies. 484 has been seen in India. 484 now is seen all over the world as a spontaneous mutation. But this 484 coming along with 417, which is again in RBD. So South Africa came with 3 mutations, 2 in RBD and 1 in RBM. Therefore, it becomes a mutation of most concern as a whole. Mutations of most concern. That was a mutation of most concern. These are mutations of most concern as a combination. Now this K147 became unstable. So it also shifted from K417N to K417T. So therefore, 417 has 2 options, either K substituted with N or K substituted with T. T means threonine. And that T was taken over by the Brazil. So Brazil have the same like a South Africa, but N gets substituted with T. That becomes the P1 strain in Brazil. Remember, now UK would like one of them to be adopted. Now they don't have 6970 deletion. They don't have 681 mutation. So therefore, if UK adopts 417 or 484, UK will become very, 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 very virulent virus. And now UK has adopted 484. The latest news last week when the UK virus mutates again means now the UK new variant has adopted 484EK. Now UK, if UK virus also adopts 417, it becomes a deadly virus. Now this is what happens in South Africa. Angelique gave me these slides, courtesy. And you can see now in South Africa, new lineage is all over. And you can see the new lineage, you can see 501 enhancing binding affinity, 484 resistance to class 2 nuclear neutralizing antibodies, and 417 class 1 neutralizing antibodies, and likely contribute towards immune evasion at this site. So these three mutations, whether it is K417N or T, these became deadly mutations. A combination of 501, 484, and 417 became a deadly combination, one in RBM, two in RBD. This is what happens in South Africa. You can see second wave is becoming. Then one of the virus was detected in Japan from Brazil, and which is nothing but the P1 strain which came in Japan, and it has incorporated 484K. Now this mutation of Brazil, which is called Brazil now has two mutations, P1 and P2. P2 is not significant. And in one case in Brazil now, both the strains are seen in the same person, and it has adopted K417T instead of N. It has taken threonine. These are the three mutations. UK mutation, then you can see the South Africa mutation and the Brazil mutation. These are the names given to this. Key mutations 501 are present in all three of them. The South Africa 484, which has now been adopted by the Kent mutation, and it also have a 41CT instead of 417N. This is what I'm talking about, that UK virus mutates again. And this UK virus, because it has now taken 484 key mutation, the vaccine will lose its efficacy. That doesn't mean vaccine will lose its efficacy to zero. Even after the mutations, even if you get the infection, you will have a cross immunity between various strains. You will not develop a serious infection and you will not die. In India also, we have seen E484 mutations, but because they are alone, they are not becoming significant. So you can see here that we have seen E484. That means this E484 is a spontaneous mutation occurring all over the world. So there is no reason why the UK strain is not going to adopt it. These are the P1 and P2 of the mutations of. Now this 484, which I want to concentrate, because now it is called mutation of most concern. It increases infectivity because it is in RBM. It is now present seen in UK, USA, Portugal, Australia. Now RBD and RBM are the major targets for neutralizing antibodies. Therefore, E484K mutation will not allow antibody neutralization, whether natural or whether artificial. So all artificial antibodies may not work here if the UK strain also acquires E484K. Now, another thing which comes is that if antibodies are formed and they are non-neutralizing antibodies, then we will start seeing vaccine-induced disease enhancement. So there is also a theoretical possibility of a vaccine-induced disease enhancement if the mutation leads to non-neutralizing antibodies. Now this is what all of you can make a picture out of it. You can take a print screen out of it. This gives you the comparison between UK, Brazil, and the South African strain, where the two things which are important in South African and Brazil is both of them have ORF1b deletion. Remember, so when there is a ORF1b deletion, it means the ORF RDRP test in RT-PCR may also become defective. So remember, ORF1A and ORF1B are a part of RDRP. These are used for RT-PCR lab detection. So if there is a deletion mutation on ORF1B and ORF1, So therefore, RDRP test may become defective. So you may not, if those labs who are doing only RDRP or ORFA 1B test, they may find the lab is not working on them. So it is important to rapidly investigate whether there is an increased rate of reinfection in previously exposed individual. I showed you the first slide where I said that reinfection rates are increasing. And if the reinfection is occurring because of a new strain, it means the previous strains, the new virus is not, the previous strain antibodies are not getting neutralized by the new strain. And if that occurs, all the vaccines and antibodies produced for the previous vaccines will not work. So this South African case and Brazil case clearly tells us that if you develop new strains, and if you get a new strain in as a part of the mutation, as a part of reinfection, that would clearly indicate indirectly that the previous strain vaccine monoclonal antibodies will not work. Last couple of slides. This is the area called NSP14. So NSP protein is non-structural protein, which are 16 in ORF1 and ORF1b. NSP14 is a part of RNA-dependent RNA polymerase. So if there is this NSP14, either it is mutated or if it is suppressed, mutations will increase. And that's what is happening when you are misusing plasma therapy, you are misusing remdesivir, or we are misusing favipiravir, who suppresses RDRP, they will suppress NSP14. Therefore, those patients who are immunocompromised, who are where the virus is alive for months together, NSP14 gets suppressed and their mutations will go on increasing. Therefore, the international policy should be that all patients who are comorbid and immunosuppressed, every weekly their genomic test should be done to find out, are they mutating, are they projecting mutation. Now, these are the two examples where I have shown that two different types of mutations, N439K and N501Y mutation, which occurred because of patients with cancer immunosuppression who survived in the first case 105 days, in the second case 154 days. Therefore, such cases, genomic study should be done frequently because these are the people who are going to mutate. So let me summarize. The virus wants, he would like to have more and more deletions of 69, 70. So the next he'd like to acquire 68 deletions, 67th deletion, 71 deletions, so that it can escape laboratory. He will like no N501D, because if 501Y becomes D, the virus fizzles out. So it will not like to acquire 501D, and it will not like ORF8 codon. It will like to delete it because it makes the virus milder. It will like from 679 mutation to shift to 680 or 681 so that it is right at its bifurcation. It will like more and more mutations in the RBM or more and more mutations in the RBD, and it would like somehow or other multiple strains of viruses enter one cell so that it becomes easier for it to mutate. What about the human intelligence? We want early immunization so that we can make herd immunity. We want vaccines. Our job is to make a vaccines in such a way that even if they don't prevent co-infection or reinfection, at least they reduce the mortality. We don't want misuse of plasma therapy. We don't want misuse of antiviral so that NSP14 is not suppressed. We should do genomics of all immunosuppressed people. We should rapidly make new vaccines to cover up the new strains. We should have the concept of universal vaccines like a Quadri or Pneumo 23. We have all the strains in one vaccine. And we also should be ready with the killed vaccine as a bridging vaccines. Whenever you find that a strain is changing, a bridging vaccine will be inactivated killed vaccines. Thank you.
Dr. Agarwal, that was such a tour de force. It is very hard to follow you. I also have so many questions after hearing your talk that I'm tempted to just skip giving my talk and instead go straight to my questions.
No. First you give your
I think what I will do, though, is go quickly through a few of the ethical considerations that have arisen. And I'm going to try to share my screen here. Doesn't want to let me share my screen. Okay, are you seeing that screen? And if so, what happens when I do this?
Not yet, Professor Matthew, we're not able to see your screen.
Matt is a co-host, no? So he should be able to do that, yeah.
Yeah. Yes,
Good.
it's starting.
Now we can see.
Are you seeing it now?
Yeah, we can see it now. Very good.
Okay, great. So I'm going to just spend a few minutes. My specialty is infectious diseases, actually, but I'm not going to speak much to the issues that Dr. Agarwal has just covered so well here. In fact, to some extent, I'm going to assume for the moment that the vaccines work and that they are very effective and that we would like to use them in the most effective way possible to bring this pandemic to a close as quickly as possible. I have a particular affinity in my sort of under my bioethics hat of looking at issues where people of goodwill can come down on very opposite sides of thorny ethical dilemmas. So we have a whole podcast that we produce called Hard Call, which is entirely about, each episode is about an issue where people have really thought hard about it and come down on very different sides. So I'm going to focus a little bit on that. I tend to think in terms of the ethics of pandemic response in terms of three buckets of issues. There's one around the rationing of scarce resources. There's another bucket around restrictions on liberty, issues around quarantine, isolation, forcing people to take vaccines, that kind of thing. And then a third bucket, which is around professional responsibilities and our responsibilities to each other. Sort of what do we owe each other in, during, and after a pandemic response. So I'm gonna bucket things in those, what I call the 3 R's: rationing, restrictions, and responsibilities. So let me start by just saying there has been a great deal of work on the ethics of vaccine allocation. And this did not start with the pandemic from COVID-19. We had a lot of work around pandemic response and vaccine allocation in 2009 with the H1N1 pandemic. So come September, October, when it became obvious that we were going to have vaccines in the marketplace very quickly, the National Academy of Science, Engineering, and Medicine and the U.S. Centers for Disease Control, as well as many organizations around the world, started thinking very seriously about how to allocate this particular vaccine for this particular illness. I'm not going to go into these details because I think the bottom line to be said is that there's a great deal of consensus around the basic ethical principles that should govern the distribution of a scarce resource like a vaccine. You want to try and optimize the benefit that you receive from the vaccine while treating people with equal concern and trying to mitigate inequities so that your distribution process does not lead to the more disadvantaged populations receiving even further disadvantage as a result of how you choose to distribute the vaccines. And then there these procedural principles. This is what many call procedural justice. Issues of being transparent about your allocation protocol, using good evidence, having an engagement process so that people can be involved. And what comes out of the other end of these deliberations are things like this. And so in the US, you saw, and I'm again not going to go through the details here, but you saw multiple organizations, starting with the national academies, but then being adopted by also the CDC and many states. So the CDC, for example, picks up on this and says, here are the ethical principles and the essential questions that we want to ask. And these essential questions are the things that you and I would, think to be sort of obvious. Who's the most likely to catch this? If they catch it, who's more likely to die? And how do we try and sort of target vaccine to those communities that are being hardest hit by this virus? So the questions are things like, who's going to spread this to others? Which, by the way, leads me to one of the questions I'm going to ask Dr. Agarwal in a moment around maybe targeting early vaccination to people with immune deficiencies, because they seem to be more likely to catch this illness and then to hold on to it for long enough to develop a number of different mutations, which can then escape them and infect others. What extra resources should be used to ensure that your distribution plan doesn't end up further harming the already disadvantaged? So a recognition that sometimes the most efficient plan may not be the most equitable plan. The most equitable plans may require more resources to implement. There have been a lot of debates, and we have an entire episode of our podcast about this, about the role of reciprocity and social utility, the idea that certain groups of people have given up a lot in the context of fighting this pandemic, and do we owe them early access to a vaccine or early access to other therapeutics? Should you target your vaccine to people with greater so-called social utility? A lot of ethical deliberation and debate about this for very obvious reasons, because once you start down the path of looking at who's more valuable in society and who's less valuable in society, that's a very difficult and slippery slope. So again, I won't go into the deliberations on that, but to say that several organizations have said you should look at some level of narrow social utility. Others are very opposed to that, and I think they both have very good arguments. Here's what has actually happened in the US, and then I'm going to turn to the international arena. States in the US were allowed essentially to implement and create their own vaccine distribution plans with this guidance, this broad guidance from the national academies and the US CDC. And the consequence of this is that there are widely disparate protocols across the US. And so we're seeing people now crossing state lines in order to try and get a vaccine because they are eligible in Kansas, but they're not eligible in Oklahoma. And so they drive up to Kansas to see if they can get the vaccine there. We also in the US are not seeing as good of uptake and utilization of the vaccine as quickly as has been seen in some other countries. So let me turn to the UK for a moment, where I think very early on, the folks thinking about allocation of vaccines in the UK realized that having a nuanced protocol that takes into account issues of, very sort of nuanced and discrete issues of equity may end up being harder to implement on the ground. And so the thing that strikes me looking at the vaccine allocation protocol in the UK is the very almost exclusive, not entirely, but almost exclusive focus on just getting this into people by age, recognizing that age is something that is easy to detect, where we've got information about that. We don't have information in the US, at least, on everyone's health records. right? We have privacy rules which might preclude people from being able to look into your health record in our country, so that it becomes a challenge if you're going to use, do you have diabetes, or do you have COPD, emphysema, or do you have heart disease, or do you have an intellectual disability? Those types of things, although all of those are risk factors for more severe COVID-19, they are things where the person doing the vaccination may not have access to that information. So strictly allocating on the basis of age is a more efficient way to get vaccine out. So as of this last week, the UK was delivering about 500,000 doses of vaccine per day. The US is delivering about 1.3 million shots per day. So about double, a little more than double, but remember that the population of the UK is about 70 million, and the population of the United States is about 330 million. So we're almost 5 times the population size, but only about double the number of vaccines going out per day. So we are not vaccinating our communities in the US as fast as vaccine distribution is happening in the United States. And the consequence of this is that, again, as of this last week, I believe the UK has vaccinated about 16% of the total population. The US is sitting across the board at around 8%. The state that's doing the very best in the US is Alaska, which is at only about 13%, but there are a number of states that are at 5% or less in the US. So we've seen not as efficient of a distribution of vaccine, and it may be that when developing vaccine allocation plans, the ethics of this are counterbalanced to some extent by wanting to get this into people's arms as quickly as possible. As Voltaire said, sometimes the perfect can be the enemy of the good. So here are the 2 additional issues that I want to put on the table. What is the responsibility of wealthy countries to share their vaccines with the developing world? And I think there are a few considerations that ought to be on the table here. Number one, Dr. Agarwal has very nicely illustrated, I think, that if this virus continues to run amok in some parts of the world, it will continue to mutate, and it will continue to put all of us at risk from the development of resistant mutants. There are also, by the way, economic reasons. There was this report from the National Bureau of Economic Research just last week said that if wealthy nations are fully vaccinated by the middle of this year, which seems possible, but simultaneously, the developing world is largely shut out of vaccination programs. The global economy over the next year could suffer losses exceeding $9 trillion. That's a sum larger than the annual gross domestic products of Japan and Germany combined. And not only would this $9 trillion loss occur, but half of those costs would be absorbed by wealthy countries like the US, Canada, and Britain. So there is a distinct economic cost to our failure to figure out how to share these vaccines, even while they are a scarce resource. And I'd also like to put another prudential reason on the table, which is there are long-term reasons why it is valuable to the United States and to England and to the EU to be a trusted ally to the developing world. And I think it's very telling that if you Google right now, China delivers vaccine to, you will see that the last word fills in with Senegal, Indonesia, Gaza and the West Bank, Pakistan. So China and Russia are very explicitly reaching out to the developing world and delivering vaccine to the developing world. And I think there are good reasons for that. And there are equally good reasons why the US and the EU should be doing the same, i.e. reaching out to the rest of the world to be a good neighbor and to ensure that for both prudential reasons as well as ethical reasons, that we are seen as a trusted ally. And then the final point that I want to make here is this one around restrictions on liberty. And should it be the case that vaccination might become required for travel, for work, for dining out, for entertainment? And there is a rather ugly history in the US, at least, of using vaccine passports as a discriminatory mechanism. This is over 100 years ago. It was yellow fever epidemics. But I think we do need, if we're going to have vaccine mandates or vaccine passports for access to certain services and so on, I think we need to very closely monitor those to ensure that, again, we are not further disadvantaging those who are already at a social disadvantage. Legally, in the US at least, it's probably legal to require COVID vaccination. The question really is it ethical? So I will close with that and ask actually what is our time here, because I fear we may be over time.
Yes.
Dr. D'Souza, where do we sit on our schedule?
Well, I think we are running a little bit over time, Mary, because our next part of it, you want to ask your question to Dr. KK Agarwal, and then we'll hand it over for the question and answer that we have to Dr. Mary, who will moderate that section. Is that all right, Mary, with you?
Yeah, I think Professor Matthew, you can go ahead and ask your questions to Dr. Agarwal. And
For this part of it, to complete what we...
Yeah, let me just ask one. I had a half a dozen, but the one that is of most interest to me in terms of vaccine allocation is whether it really makes sense to very carefully focus vaccination to people who are immune compromised. Even though I tend to think of that as not being a really effective way to use vaccine because they don't often respond to vaccine that well. But from what you're telling me, I'm hearing that this is essentially a petri dish in which vaccine-resistant mutants might arise. So even with the lower response rates to vaccine, I'm wondering if you would recommend focusing early vaccination on people who have immune compromise in one way or another.
So I just want to say a couple of things. One is that unfortunately, there are 33 deaths in Norway, 10 in Germany, 19 in India, who have died after the vaccination. All of them have different reasons. So after Norway got deaths, they said no vaccination after 75, so which is again unethical from my point of view. Germany said we will not vaccinate elderly. And yesterday, Pakistan said we are not going to give vaccine to 60 plus. So then whom you are trying to save? So my answer is that all people who are high risk, immunocompromised, who are likely to transmit mutations must be vaccinated on priority and at the earliest. To reduce mortality, we have at Confederation of Medical Association of Asia and Oceania, we have made certain protocols that first vaccination will not cause IgE anaphylaxis because IgE anaphylaxis will come with the second dose. For non-IgE prophylaxis, for people who are elderly and immunocompromised, you can give them under cover of Montelukast, H1 and H2 blocker. For immunocompromised people, to prevent non-IgE anaphylaxis, you can give them a immunomodulator dose of a steroid. And those people who are very high risk and pro-inflammatory and pro-thrombotic, who C-reactive protein baseline is more than 1, to prevent ACS, give ACS. To prevent acute coronary syndrome, give them ACS, aspirin, colchicine, and statin. That's what we are following. So all those people in the countries who are, because there are many countries who says, these are the people we are not going to give. So make a contraindication and indication. Give on priority immunization to all the people who are immunocompromised so that they don't go on manufacturing. They are the manufacturing units for the mutations.
Thank you. I'll turn it back over to Mary for the panel discussion.
Thank you,
Okay,
Dr.
Mary,
Matthew.
Thank you.
So I'd like to thank Dr. Agarwal. You're a walking encyclopedia on COVID now and a reference point for all of us and for the world. Thank you for the information. I think many of our students also are here who have joined us. So, it's helpful for all of us. And to Professor Matthew, thank you for bringing the ethical aspects, and that is what is important at this stage. We are talking about vaccinations, and there's no time that we have seen such an ethical, issues coming, coming forth at a time during this pandemic. And what I'd like to do is first let me ask Dr. Agarwal before we lose him. I hope he will stay till the end. There is a question in the chat box from Dr. Ratna Rao, which says, if we find a vaccine which paralyzes the generation of mutation in the virus, do you think that that will stop all replication, reinfection, and spread?
See, at this moment, I am only asking one question is that why can't we, when we have a genetically engineered mosquito, and when we know which mutation will work and which mutation will not, and when we know that a virus vaccine can be made in the labs, and when we know the original virus may have been originated in the labs, I'm only saying query. Why can't we make why can't we make genetically modified virus and introduce specifically in high-risk people, specifically in people where the virus is replicating in the body, and do that? That's what my take will be, that we should look for genetically modifying, making viruses and introducing them in the body of the people. Even these people who, with Matthew mentioned about that they are, these are the people who are mutating all the time. Why can't we introduce them less harmful strains so that they compete with each other, something like that? So I will take it up more on the therapeutic side than on the natural mutation side.
All right, thank you, Dr. Agarwal. Just to Dr. Matthew, you had mentioned about China and Russia giving, sharing their resources and vaccine. But please correct me if I'm wrong, Dr. Agarwal. India is also sending vaccines to other countries, if I'm not mistaken.
15 countries they have sent the vaccine. 25 more countries they are sending. In total, 40 countries vaccines are being given by the Indian government. Yeah, they all are Covishield. Yeah. They all are the Serum Institute, which is the Oxford type of a vaccine.
Oxford AstraZeneca.
They are not distributing the killed vaccine as on today. They are all distributing the Oxford vaccine, which is the number 3 vaccine after Moderna. And so 40 countries India is going to distribute.
Yeah. Thank you, Dr. Agarwal. Some of our audience have raised their hands. I request you all to put the questions in the chat box so that we can ask our panelists the questions. So I think that will be a better way to move forward. So thank you. We'll move to the second part of our webinar, and that is the Q&A session. I will bring in Dr. Barry Shubs from South Africa first, because I understand that he has to leave. So, Dr. Barry, are you there? Dr. Barry, can you unmute yourself and put on your video?
Hi, good afternoon, good morning, and evening.
Yeah, Professor Barry, thank you for joining us today. And we are interested in South Africa because of what is happening and the deadly strain that is there. Could you share with us what is happening in South Africa and regarding the vaccine? Which are the vaccines that South Africa is using, and would it work on the current strain that is there?
Yeah, thank you very much for inviting me. Yes, we do have a major problem. This particular variant, as the previous speaker mentioned, has got 4 mutations. It's the 501, the 485, 484, 417, and also in the N-terminal domain. So you really need to ask, and this was first detected in South Africa. We're not sure, they often call it the South African strain, but I'm not sure how accurate that is. It was detected here because we've got a very good genomic surveillance system in the country. But in either event, it was first detected in the eastern province of South Africa, which is at the kind of very southern tip of Africa, and then spread very rapidly, detected first in October, and now it is probably the dominant strain in our country. So of all the strains which we've isolated, it's about 90 to 95% are this new mutation. We call it the 501Y variant 2, to distinct from the 501 variant 1 from the United Kingdom. And these mutations obviously do confer, as the previous speaker mentioned, a couple of major problems in its properties. So we really need to ask 4 questions. The one question is it more infectious? And then I think we've established that it's probably about 50% more contagious or more infectious. The second question, of course, is it more virulent? Is it causing more severe disease? And there we've looked at our first wave, which had the original 614 variant, or the original strain, and then the second wave, which has got the 501 variant. And we looked at various parameters, hospitalization, ventilator, mortality, etc. And there didn't seem to be any difference. In other words, it didn't seem to be either more or less virulent. Then the third question is if you've been exposed to the previous variant, the previous virus, would you have immunity to the new variant? And we looked at sera, and there was a dramatic reduction in neutralizing antibodies. Okay. Both a pseudovirus neutralization test as well as a live virus. And in fact, about 50% of the sera, there was 0 neutralization. The rest of the 50%, they were certainly significantly reduced. The last and probably the most important question we don't really have a final answer on, and that is post-vaccine immunity to the various vaccines. Now, we've done it in vitro tests in the laboratory, and so far there is a significant reduction of neutralizing ability from just about all the vaccines. The one vaccine, which of course we are most interested in at the moment, is the AstraZeneca vaccine, AstraZeneca Oxford vaccine, because that's our start off for our rollout program. And the countries imported from the Serum Institute of India 1 million doses this month and 500,000 next month to start off with the highest priority, which is our healthcare workers. So at the moment, there is a lot of concern. We're not quite sure because one of the other big problems is that the only data that we can have of how effective the vaccines are against the new variant is where it's been rolled out in countries where the variant is dominant. And of course, in South Africa, we haven't had the rollout yet. And we're the only country where this particular variant is dominant. Brazil's got a similar, but not exactly the same as ours. So the only people that we can really look at are the people who volunteered for the 2 trials, the trials of the AstraZeneca and the trials of the Johnson & Johnson. And we're waiting for the data to come out of that. We did a trial on the Novavax vaccine, and there was a reduction to less than 50% of neutralizing. So it is a big, big worry, and we are waiting probably either today or tomorrow results of the AstraZeneca to see how. But we are certainly very worried that there will be a considerable reduction of neutralizing ability using the AstraZeneca vaccine.
Yeah, Professor, there's a question from Dr. Matthew regarding stigmatization, naming it the South African vaccine. Do you think we should do this Brazilian vaccine mutant and the South African variant, those kind of words? Probably we should do away with that because it's quite stigmatizing. And I agree with it. That's how we've changed names of so many diseases.
You're absolutely right. And it's something which we've kind of fought against because it has got a lot of implications, the stigma. Got implications for travel, got implications, economic implications, and so on. So for the meantime, we're calling it the 501Y variant, 501YV2 variant. But that's a bit of a mouthful, and certainly for people that are non-technical, yes, it's much easier to say the South African variant. So we need to figure out another name, which will be easily roll off the tongue, but won't be a stigma. Yeah. Because quite honestly, this particular variant is not a South African variant. It was detected first in South Africa. But this particular variant, I'm sure, is pretty widespread and is very, very similar, as we just heard, to the Brazilian variant. Yeah. And now I'm calling it Brazilian variant. Because that's true. We need to kind of have a very person skilled in language to kind of get kind of very easy labels for these viruses, which are not
Yeah.
going to be stigmatized.
Yeah, it's like how President Trump said the China virus, which, you know, it's quite stigmatizing when you say things like that. Yeah.
With
that's true.
implications as well, yeah.
Yes, yes, that's right. And is there a vaccine reluctance in South Africa?
At the moment, unfortunately, there is, which is very surprising because we don't have vaccine reluctance to any of the other vaccines.
Yes.
It's just for this particular vaccine. There was an Ipsos study which showed that only about 57% of the population who was surveyed, and it's a pretty cross-sectional survey, would take the vaccine. So we do have a lot of work to do, and we have already started working on vaccine hesitancy.
But have they found the cause of the reluctance? Is it is the government providing it free, Professor?
Yeah, it's going to be provided free. The government is buying it and providing it free. That those people that are on a health benefit, what you call a medical aid in our country, they will pick up the tab. But to the person, it's going to be free. The main reason for the hesitancy is really when you ask people, they're scared of the side effects.
Yes.
They're worried about the side effects in the long term. I don't think the conspiracy theories have played a very significant role. And that's why we are optimistic, because I think education should overcome that. Conspiracy theories are not always easy to overcome.
Yes. Do you think the leaders of the country should be vaccinated so that they will be an example to allay the fears of taking vaccination?
I think they should. And I think they should be representative leaders, leaders of communities, leaders that people look up to and respect, not just political leaders.
Yes. I think probably that would go a long way in allaying the fears of vaccination.
Absolutely.
Yeah. Thank you, Professor. Thank you very much. I'd like to
you.
go to Professor Martin Mickey. Professor?
Hi. Hello.
You've been waiting a long time.
It's okay.
Very patiently.
Learning.
Yes. Professor Martin, I won't say UK strain now, but you do have deadly mutant viruses going on there.
We do.
Yeah, and from Professor Agarwal's lecture, it looks like you're going to. There seems to be add-on mutants to the virus.
Well, that's the case. That's true. And as you say, there was a strain which emerged first in Kent, in the southeast of England. And I think what was the clue at the beginning was that the restrictions that were in place were no longer controlling the spread of the virus. And that was particularly worrying. So it seemed to be breaking out despite having controls, restrictions in place that had worked up until then. Now that strain of that variant has now spread throughout the country and is becoming the dominant form across the country. But in addition, we are having a number of imported cases of the, whatever we want to call it, South African, Brazilian, but the other variants. And in addition, we're now getting the E484K mutation arising apparently spontaneously in the quote unquote Kent B117 variety. And the real issue, I think, for us is the increased transmissibility. I think what many of us were worried about at the beginning, the variant appears to have arisen in about September. The first case was identified about September the 20th, but for a very long time, up until about November, it seemed to be circulating at a very low level. Now, of course, we know with this virus, it spreads through super spreading events. So once it gets into a super spreading event and then goes to a series of them, it can explode rapidly, even though it's been at a low level throughout then. But then by November, December, it was really taking off. So I think many of us feel that there was first of all, the thing I should say is that the United Kingdom has not done well in controlling the pandemic. We have had the highest death rate in the world, the biggest economic hit. So, there have been major problems. And the difficulty, of course, is that when you have high levels of circulating virus, as has been pointed out by the other speakers, you are creating the conditions for mutations to arise, and linked to that if you have people who are being treated with convalescent plasma and so on. And there is some suspicion, although I don't think it's been proven yet, about the role of that of the convalescent plasma in the emergence of this variant. But leaving that aside, the problem was we've had high levels of circulating virus, and that of course is why we have these. And I recognize the problems with the names, the English, the South African, the Brazilian. We don't hear about large scale spread of an Australian variant. We'd heard Dr. Agrawal mentioned one, but it didn't go any further. We haven't had a Finnish one or a New Zealand one. And so I think the problem is that countries like the United Kingdom, Brazil and others are following policies that are allowing variants to emerge.
Yeah.
And I think that's a major problem for the rest of the world, to say, how do you respond to governments that are failing to act when they have clearly the ability to do so, because the United Kingdom has a very well developed public health infrastructure if it was used, and that's another issue. But it is there, it's got a very strong science base, but we, for whatever reason, we have failed to control the pandemic. What we're seeing, just to follow on from what the other speakers were saying, is vaccine rollout has been excellent, and it really has worked. I think this is particularly gratifying because the earlier parts of the pandemic response, the testing and the tracing, have been marked by failures, major failures. And of course, in those cases, the government had done what it had done for about a decade when faced with a complex problem, and gone to one of the outsourcing companies, the ones that have repeatedly failed, be it with security at the Olympics or whatever. But for whatever reason, with the vaccine rollout, it went to the National Health Service, and their people working in the National Health Service have done a remarkable job, often organizing themselves and doing things voluntarily and going beyond the call of duty. So I think that is really good that has happened. Now, of course, one of the more controversial decisions has been that the UK has gone to maximize the number of people getting one dose of the vaccine and then delaying the second one beyond what was in the clinical trials. And that's been there's been a lot of discussion on that. We looked at this in the independent stage, and I stress I'm a member of this independent group, which we don't advise the government, but we engage with the public. We actually agree with the official sage on virtually everything. I think everything where we overlap, but where we differ is that we decide the questions we want to ask, and then we look at operational and policy matters, whereas they're restricted to looking at a very extremely narrow definition of science from modeling and so on. So we can look at, here is a proposal, would it work? So we looked at this and we took the view that the government has made the right decision here because of the spread of the new variant and our inability to control its spread with the existing measures. And we need to get as many people vaccinated as possible with at least one dose, given that we do know that one dose does give a reasonably good degree of protection, even if 2 doses will give better. So what we're seeing in terms of vaccine uptake, it is good, but there are big gaps in uptake by ethnicity. Okay. And we're seeing much lower uptake in people from Black, Asian, minority ethnic groups. And that, I think it is fair to say, is not for want of trying to roll out the vaccine. I think those involved in the vaccine program recognize that this is an issue and are working very hard to overcome it, working with community leaders and so on. But it is also true that there are that is where we are seeing the problems of vaccine mythology, the fake news, the disinformation and so on. And there are concerns about, and people will be familiar with them, vaccines being a form of, injecting microchips into people, being associated with infertility and so on and so forth. I think that what is quite good is that at least the UK knows that, whereas in many other countries, they're not even collecting data by ethnicity if we look across Europe. And I think that is a long-standing problem, but it doesn't excuse the fact that we clearly need to do more. And I think, as we in Independent Sage have been saying all along, we really need a very powerful push for co-creation of policies working with community leaders, and particularly from communities that have tended to be marginalized and where there is a low trust in
issues, yeah.
politics. So I'll stop at that point and take other questions.
Yeah, Professor, the thing is, because the maximum number of deaths also happened in the, the African American and the Asian community when it came to healthcare workers. So that is really a very important issue to look into, because they are the ones who probably may actually need the vaccines more than, when you look at the others.
Yeah, and that has been discussed quite a lot. And as one of your previous speakers said, the Joint Committee on Vaccination and Immunization has stratified the risks very much by age, apart from for healthcare workers and social care workers, but otherwise it's based on age. The reality of it is that there are large gaps in life expectancy around the country, both by geography and by ethnicity. And there has been an argument that it should be stratified in some way. The difficulty, of course, is operationalizing that, because you have an intersectional problem of ethnicity, social class, and other things. So, you could say, well, look, there are a number of, for example, Asian billionaires in the United Kingdom. Are they at any greater risk? Almost certainly not. But as a group, the problem is that you've got two sets of curves that do overlap quite a bit, and to try to turn that in. But the same is true of age, of course, because people may have the same chronological age, but not the same biological age, depending on their life experiences.
Yeah, another thing is also about, there are talks about mixing the vaccines. The first dose is of Pfizer and the second dose is of something else. So that is a new thing that we're hearing in UK.
Yeah, and there is a trial underway with a first dose of AstraZeneca and a second with the Sputnik vaccine, and another one has just been announced, which will be first AstraZeneca and second Pfizer-BioNTech. There are theoretical arguments. I mean, there are people who are more expert than me on this webinar, and there are arguments for heterologous vaccines, because you may get a degree of additional boost from having that, particularly when you have emerging variants. So I think it will be interesting to see. The AstraZeneca Pfizer-BioNTech one is a factorial design. So they're looking both at different orders of vaccine and also different intervals. So
and different age, are they looking at age too?
Well, they will be within it. I think, as we all know, the AstraZeneca trial was problematic because it had very few over 65s in it. And hopefully they won't make that mistake again. Unlike the Pfizer-BioNTech and the Moderna ones. That was, I think, unfortunate. And in a way, because of some of the other problems in the trial, they got some interesting results, but by accident, particularly around the delay. But clearly, it's very important to look at difference at the effectiveness of vaccines in all ages. One of the other problems we have at the minute is the very limited data on children.
Yes. And are children a priority in the vaccination list in UK?
No, they're not. No,
they're not.
No.
But
so
school
the government
teachers are.
No, they're not. No, and there's been a heated debate about that. School teachers. The difficulty is that, of course, there are many people in schools other than school teachers. There are support staff, many of whom themselves are from minority ethnic populations and who are often older and who may be at greater risk. So I think but I think the difficulty with the school situation is the debate has been highly polarized. And the extent to which transmission happens in school. And I have to say, it's not been particularly edifying, because while everybody recognizes the importance of children being educated and socialized in schools and so on, my sense is that some of those who are arguing that schools pose a very minimal risk have been somewhat selective in their interpretation of the evidence. And certainly the evidence that I've looked at, particularly Sarah Rasmussen in the United States and others who have looked at the data on schools, does seem to suggest it is complicated, in that children probably do play a very low risk when there's little community transmission or a low prevalence among children. But once they get above a certain level, it does change dramatically. So I think the situation in schools is much more nuanced than we often recognize. But unfortunately, it has now degenerated into a highly polarized debate between some groups. And the other problem here is, I think we also need to look at the role of schooling, because I think there are some people who are arguing against taking measures in schools claiming to have the best interests of the children at heart, when frankly, I suspect that some of them are looking at schools as a way of storing children to allow the parents to get back to work. I'm afraid some people are being a bit disingenuous in that.
Yeah, that's true. There may be multiple reasons to that. Thank you very much, Professor.
Mary, can I include that Professor Martin is also the advisor to the European Union. So any getting a view of that, and he was the president of the European Epidemiology Association or so. Is that right? So you have a fair amount of understanding of what's going on that part. That's
I'm a member of the European Commission's expert panel on investigation.
That's what I said.
And we have published a report recently on COVID resilience. We've also published one on procurement, which looked at a lot of these issues. So I advise in that role, and I'm also involved in various other roles, but that's the main one. So I wouldn't elevate it too much. But also within the European Observatory, where I'm the research director, we have a COVID response monitor online. I can put the link into the chat. And there we bring together data from across Europe, which provides a very detailed review, and I have published quite a lot on what's happening. I happen to live in the United Kingdom, but I would stress that I just live here. I am a European, my expertise is in Europe, and I'm a European citizen.
All right. Okay. Thank you, Professor Barry. Thank you very much.
Thank you, Professor Martin McGee. Thank you very much.
Yeah.
And also thank our colleague, member Baroness Ilora. She's his friend, Martin's friend. Thank you.
Yeah. Before I ask Professor Antonio, I just want to ask Dr. K.K. Agarwal. We didn't speak much on the Johnson vaccine, Johnson & Johnson.
So the vaccine, all the new vaccines which are coming, they are showing two things. One thing they are showing is 100% efficacy as far as mortality reduction is concerned, and serious cases are concerned. Otherwise, on South African strains, on the on the 501 variant 2, as far as that is concerned, they are showing less efficacy. So whether it is Johnson & Johnson, whether it is Novavax, all these new vaccines which are coming, they are showing efficacy lower in the variant 2 strain than the V1 strain. But mortality reduction is seen in everybody. So the good news is new mutations are not allowing deaths to occur.
Okay. Another thing, one thing about why Johnson & Johnson vaccine is supposed to be projected as, because it's a single dose vaccine, Dr. Agarwal. Yes. So that's probably a little more convenient.
I know, but there comes it that Sputnik vaccine, and the difference between Sputnik and Johnson & Johnson vaccine, which comes out to be, Sputnik may still be better because it is containing adenovirus human with two different viruses, because we in any way get lots of adenovirus infections. So therefore, two strains will always be better than one. Okay. So how much efficacious single vaccine will be, the time will tell us. But I think Sputnik Russian vaccine will have much more advantage after Oxford that is going to lead. That's my way of looking at it.
All right. Thank you very much. Dr. Agarwal, there's one question from Dr. Hansel. It says, she says that there are many hospitals administering random doses of tocilizumab, without any specific protocol. What is your opinion on that?
Tocilizumab now has gone out of market because it is a very selective immunosuppressant. It increases chances of infections. So therefore, after tocilizumab, newer baricitinib, which is a JAK1 inhibitor, has taken place, which is much better than tocilizumab. Tocilizumab causes much more infections. So in India, we have stopped using tocilizumab. Instead of that, we have JAK1 inhibitor, which is now becoming more important than tocilizumab. Another thing which comes is when you are talking about inflammation in COVID-19, COVID-19 involves multiple inflammatory pathways. One of them is a ROS pathway where antioxidants, vitamins work. The second one is a Th1 pathway. In a Th1 pathway, you have steroids which are working at the level of TNF alpha. And then there is another pathway that is NLRP inflammasome using the NOD-like receptor pathway using the nuclear factor kappa beta pathway. There, colchicine and mefenamic acid are showing a better response to take care of these types of inflammations. So therefore, if you have a fever of less than 100, you say this is a gamma interferon fever. But if the fever is more than 101, we say this is IL-1 beta fever. And there you need to give them IL-1 beta. So instead of going into selective IL-6, we are now giving more importance to IL-1 beta than IL-6.
Okay, and colchicine is now recommended for those who are immunosuppressed and.
Colchicine is a drug which is basically in microtubular level, it modulates. It reduces NLRP, it reduces kappa beta nuclear factor pathway. And nowadays, in the last October, all the cardiological associations have said all patients with blockages with stable coronary artery disease, to reduce their inflammation level should be given colchicine. So what we are following it, if your C-reactive protein is more than one baseline, then we say you are pro-inflammatory and pro-thrombotic. In that particular situation, we give them colchicine early enough. And if on day 3, if your C-reactive protein is more than 10, if you develop high-grade fever, or if you show pneumonia, without waiting for the breathlessness to occur and anoxia to occur, we start steroid along with colchicine, and that has given us an advantage over starting steroid when the hypoxia develops.
Okay, thank you very much, Dr. Agarwal. May I ask Professor Antonio Chagas from Brazil? Professor?
Hello?
Yes, thank you for
Hello.
waiting, Professor. Thank you.
No. It's a pleasure for us. Good morning, good afternoon, good night for some of our speakers and friends.
Professor, we were talking about the various strains in different countries. Brazil is also going through the same situation. Can you just enlighten us on what is happening in Brazil regarding the vaccines and the new strain?
Yes. Okay. First of all, thank you very much, Professor Russell de Souza, and for you, Mary, for the invitation in name of the Brazilian Medical Association. And I just wanted to say that the Brazilian infections started from a patient who is a Brazilian patient who came from Europe. This was the beginning of disease in our country. And after this first patient who went from Italy, at time that Italy had a very, very bad condition, we started to have the disease in Brazil. And the disease spread very, very rapidly. We have, in the beginning of the year, between March, May, and June, July, huge numbers of cases around the whole country. I just want to remember that Brazil is a continental country. We have different kind of assistance, health assistance, but in the country, we have the government service for everywhere and for everybody. We started to have very good conditions in the principal areas like in São Paulo state and south of the Brazil, with very good results in treat patients with corticoids and also antithrombotic agents. After a while, when we began to have a decrease in the disease, we start to have again like a second wave of the disease, and with the new mutation, where Professor Agarwal, my friend cardiologist, explained very well the types of the disease and the mutation that we had in Brazil. And also we exported that mutation because patients in Japan and also patients in Europe from a Brazilian patient who went to this area also gave the mutation to other parts of the world. We started the vaccination just 1 month ago. We are starting using the CoronaVac, that's the Chinese vaccine, and also we are using the Oxford AstraZeneca vaccine. We're expecting to have the Sputnik vaccine, and also we had some trials with the Janssen vaccine in Brazil, and also the Pfizer and Moderna vaccine. And I assume that in a new in a near future, you have also the Sputnik and the Janssen Johnson vaccine in our population. The vaccination in Brazil is starting first by older people and also for the public health works and the people who is in the front line of attendance of the patients. We, like Professor Barry talking in Africa, in South Africa, we also had some people that don't want to have the vaccination, that want to get the vaccination. We needed to make some kind of public advisors and also needed to involve some public people, not the politicians, but people that are, for example, the good singers and, for example, the soccer players to say that they want to have the vaccination and also to increase the number of people that are allowed to have the vaccination. We needed to do more efforts, and I think that the medical association in Brazil and the several specialties worked very well in order to make very good concerns about the treatment. We had very good results in treating very ill patients, but we need to continue to do very good work in public health. I think that we are learning a lot with what Professor Marquis told about yield, what Professor Agarwal talked about the mutations, and I think that all that we are learning from the public health and about the ethics aspects of the disease will be very helpful to treat and also to avoid the disease in our country.
Thank you, Professor Antonio. Thank you very much for your contribution. Professor Agarwal, before you go, a question from the chat box. What do you think about the delaying the second dose 6 to 7 weeks after the first dose, Dr. Agarwal? Question is
what the UK have said, the Oxford original trial have said, if you give the first dose half and the second dose full, you are likely to get more immunity, because that's what they have said. And now Oxford is talking to Sputnik, whether you can give one of this and one of Sputnik, but that matter is still different. And then they have said, if you delay the second dose, there is more immunity. Now, it all depends upon the regulators of your respective countries who are going to pass the protocol. In India, they have not cleared that. They have only cleared one protocol, and that is on 28 days, as far as India is concerned. But yes, if we see the data, for example, the natural virus infection, 5,000 cases analyzed, we have seen only one patient with natural infection getting more than 1,000 BAU neutralizing antibodies. But with Covishield, which is the Oxford vaccine, after the first vaccine, the antibodies are more than 8,000. And after the second vaccine, the antibodies are crossing 23,000 BAU. So therefore, what they are saying is with a period over time, you may get more number of antibodies, but it will now depend upon country to decide which protocol they're going to follow. But yes, if you delay the second dose, it will happen two things. The ethical issue, what was mentioned earlier by Matthews, that you will be able to give first dose to more number of people. So if you are taking about breaking the chain, then first dose should be given to as many people as possible.
Right. Thank you, Dr. Agarwal. I understand that you have another meeting and you will be leaving this webinar. So thank you for your contribution. And as always, Dr. Agarwal is always ready to join webinars when it comes to issues of health, especially right now when it comes to the COVID-19 pandemic. Dr. Agarwal, thank you on behalf of the UNESCO chair.
Thank you, Dr. KK. But importantly, our Confederation of Medical Associations of Asia and Oceania are also part of our UNESCO chair and Bioethics program with me. Thank you, KK, very much. We also, you have the other confederation with the link in there with taking another part of the world along with Brazil, but Caribbean and so forth.
Yeah, before I go to Professor Lincoln, may I ask Professor Siddharth to just come in? And Professor Siddharth is from Hong Kong and he's a virologist, correct?
Yes, hi.
Hi. How is Hong Kong doing, and how is the vaccination program, and what are the issues you're facing there, Dr. Siddharth?
Yeah, well, in terms of number of cases, we are doing quite well. We've had about 10,000 cases all in all since the start of the pandemic. And there's always been a commitment to maintaining zero COVID in the community. So even now we are implementing very tough measures to keep COVID under control locally. So so it's not been as much of an issue in terms of, full hospitals, full ICUs, lots of people dying. But obviously it's caused a lot of societal disruption, as with anywhere in the world. We've had, not quite lockdown, but things like restaurants closing early, people not being allowed to go out, social distancing, things that are, I guess, we share with many, many other parts of the world are going on here as well, with a lot of economic disruption. So that definitely is something that people can't wait to see an end. In terms of vaccination, we are in the middle of the queue. We haven't started yet. We might be starting at the end of February or March. We are looking at 3 vaccines at the moment: Pfizer's mRNA vaccine, the Chinese CoronaVac, and AstraZeneca. They're likely to come to Hong Kong at different times, so it's quite likely that most people will go for whatever comes first. Priority groups are the elderly and healthcare workers, so it's very similar to what's going on, as the other speakers, panelists have noted.
So do you having a good response when it comes to vaccine, taking the vaccine?
Yeah,
are people optimistic and expecting to take the vaccine?
Well, generally, vaccine uptakes are good here. Like, say, for other things like MMR and things like that, you want 95% plus. With COVID-19 vaccines, there is a lot of misconceptions among the public, but it's more to do with which vaccine to get, because we're getting 3. Rather than whether to get a vaccine or not. So I'm pretty optimistic that most people will take the right decisions for their bodies and get some kind of shot for COVID-19. The main concern is that we are now kind of at the end of a 4th wave of COVID-19 locally. So as the number of cases go down, public awareness or concern about the pandemic situation tends to dwindle. So then we might see a situation where people are less reluctant to get it because it's not a pressing concern for them.
Yeah.
So hopefully, people will make the right.
I think that it's the same here in India, because the cases are coming down and people are questioning whether to take the vaccine or not. So that is an issue that's going to come up now. And what about regarding the strain, the new mutant strain? Is it there in Hong Kong or? No,
we have detected B117 and B1351 using the official names here. And these are mostly in imported cases. So these are travelers who come from overseas. So we detect the new variants in imported cases. It's not transmitting locally as yet. So we have a pretty strict policy on quarantine of new arrivals for up to 21 days. And they get tested repeatedly throughout the process while they're staying in a dedicated quarantine facility or hotel. So we catch patients infected with these variants quite early and make sure that they're well isolated until they are cleared, basically. So the variants are not circulating, but we're looking at...
Is the expense on the government or is it on the patient, the person who comes?
Yeah, it depends where they're staying. If they're staying in one of the hotels, then the expense is shared by the traveler and the government. So it's actually subsidized fairly heavily. So it depends what kind of quarantine accommodation you want. You can choose 2-star to 5-star.
Okay, right. Okay, so you're given a choice there. Okay.
Yeah.
Yeah. Thank you. Thank you, Dr. Sridhar. And our final
Ritu?
panelist for today, Dr.
Yes,
Lincoln,
how are you, sir?
Professor. Thank you for waiting. You've been on
Ritu,
our
you can
webinar
close
before.
that
You can
meeting,
unmute
Ritu?
yourself, please. Yeah, there you go.
So
Ritu?
once again, thank you very much, Professor Russell, Dr. Mary, for the
You close
opportunity.
that meeting now.
I'd like to have
Your,
to
yeah, you can close
contextualize
that meeting
my
now.
speeching for the people that weren't here in the last presentation. I represent here, although I'm living in Brazil, I'm Brazilian, the Confemel, that